Hey, D-Dexter here again with another great math video for you. This time we're talking about the derivative of e to the x. So derivative of e to the x. So let's look at a couple basic rules here we have for us. Properties, if you will, of the derivative. So the derivative of e to the x is just e to the x. Okay. Now, if there is some value up here, maybe 2x plus something, it's more than just an x, then what we need to do is we need to do the derivative of e to the u. And the derivative of e to the u is e to the u times u prime, or the derivative of the exponential powers, whatever it might be. So let's look at a basic example of this. Example number 1. Let's say f of x is equal to 2e to the 2x minus 1. So now we've got something a little bit more complicated than just an x. So we have 2x minus 1 up top. So what we're going to do is we're going to let u equal 2x minus 1. We take the derivative of that, and we get du is equal to 2dx. And then we need to just simply multiply this times the rest of the function. So we get 2e to the u times 2. So we put it all back together. 2 times 2 is 4. And we replace our u with 2x minus 1. And so we get 4e to the 2x minus 1. All right, example number 2. In this case, f of x is equal to e to the negative 3 over x. Okay? And so, again, we let u equal negative 3 over x. And when we do this, we can simply rewrite this as negative 3 times x to the negative 1. Remember your exponential powers. If there's an x in the denominator, we can move it up top by making it to the power of negative 1. When we do that, we will bring, you remember your derivatives, we'll bring this negative 1 down, and that will be a negative times a negative, which will give us a positive 3. And then we have to reduce the power by 1. So once we reduce the power by 1, we get a negative 2, which will give us the du is equal to 3 over x squared. So then our derivative, f prime of x, will be e to the u times 3 over x squared. And we replace our u again with the negative 3 to the x. So we get 3 over x squared times e to the negative 3 over x. All right, let's look at even a little bit more complicated one. One that is going to require the use of the product rule. All right, remember the product rule is f of x times g prime of x plus g of x times f prime of x. There's lots of other ways to remember the product rule, but this is basically it. So let's say we want the derivative of x to the square, or x squared, times e to the 3x. So this g function, now we also have e to the x, but it's also 3x. So again, we're going to have the product rule, as well as we're going to need some U-substitution as well. So remember, f of x, well, that's just the basic function, x squared. We called f x squared, and we called the g function e to the 3x. So bring this down, that's x squared, times the g prime, well, remember it was e to the u, so our u would be 3x. Take the derivative of 3x and we get 3. So we put it back together, it's e to the 3x times 3 plus the regular function, which is e to the 3x. And now we need to take the derivative of the f function. It was x squared, the derivative is now 2x. All right, so rearranging some values here, it's multiplication, so because of the community property rule, we can just move this x all over, these multiples, right? We can rearrange them, so we get 3x squared times e to the 3x plus 2x times e to the 3x. Now you could be done there, but sometimes you might want to factor some things out to make it a little more simplified. So we recognize that each of these has an x, and they both have an e to the 3x. So here's an x squared. This one only has one x, so I can only bring one x out. So we get x times e to the 3x times the quantity 3x plus 2. All right? So that has been 3 examples of how you take the derivative of e to the x or e to the u. Again, here's the basic rules again. Leave that with you. All right. Hope you have had a great time. Thanks again. See you soon. Peace. Keep it mathy.